Hi everyone. Let us solve today's problem of the day, that is intersection of two sorted linked lists. Let us go through the problem first. Given two linked lists sorted in increasing order, create a new linked list representing the intersection of the two linked lists, right? So the new linked list should be made without changing the original list. Okay, so the elements of the linked list are not necessarily distinct. All right, so what does the question state is that we have been given two linked list, right? And we need to return another linked list. Basically, we need to make another linked list such a way that it should contain all the common elements, right? So for example, we have been given, this is the two linked list that we have, right? 1 2 3 4 6, and another linked list has 2 4 6 8, right? So these two linked lists, in both of these linked lists, we have what are the elements that are common. We have 2 as common, right? Because 2 is present in the first linked list and then in the second linked list, right? We have 4 as common and 6 as common, right? So 2 4 6 is the linked list having the elements common in both the linked list, right? So how do we actually solve this problem? Before that, let's go through another test case that we have 10 20 40 50, and then we have 15 and 40, right? So what is the only, so 40 is the only element that is common in both the linked list, so we will be giving it as output, and this is in the linked list form, right? So what are we going to do is that we, since these linked lists are sorted, so whenever we have these keywords like sorted, so you should always think of something like binary search or two pointers approach, right? I've already told this in my earlier videos. So if we think it about in an two pointers approach, what we can actually do, okay? So what is the advantage of having a sorted linked list is that we are very sure, okay, that if at one point I have a smaller element, then it is not going to occur in my other half of the linked list, right? So what am I trying to say is that let us consider two pointers that is at first linked list and in the second linked list. Okay, so these are the two pointers that we have, right? So what can be the three cases that can arise? So there can be only three cases that can arise between these two pointers. So either the data of head 1 is greater than the data of head 2, right? Or the data of head 2 is greater than the data of head 1. Okay, and the third case can be both of them are equal, right? So we want this third case only, right? Why? Because we need to have a linked list containing only the common elements. Okay, so we only require this third case. Okay, so we'll be seeing how we are going to approach this problem. So whenever we have the two pointers that is at head 1 and head 2, right? So what we can do is we can check, okay, so in which of these three categories these two pointers data are coming. Okay, so let's see that we have a 1 and then we have a 2. Okay, so 1 is smaller than my 2, so that is coming in my second case, right? So where my head 2 is greater than my head 1. So if I have a smaller element, so generically speaking, I am very sure that this one is not going to occur in my second half of the linked list, of the first linked list, and nor in the second linked list, right? So why? Because these linked lists are sorted, right? So whenever we have a smaller element, it is not going to be occurring in my first linked list or in my second linked list after this particular point, right? So that is why we will be incrementing this particular pointer, pointer 1. Okay, so we'll be incrementing this particular pointer to its next element, right? And this pointer 2 remains the same. Okay, so now if we see that we have a 2 in the first pointer, and in the second pointer we have again 2, so since that is the third case that we have, we will be joining it to our answer linked list, right? So we'll be joining it to our answer linked list, and we will increment both the pointers. Okay, so we will increment both the pointers. So now we have 3 and then 4 in the second case. So again it is the second case that we have where head 2's data is greater than head 1's data, right? So in this case again, I'm pretty much sure that my 3 element, whatever the 3 data that I have, it is not going to occur in my other half of the first linked list and other half of the second linked list, right? Because why? Because it is smaller. Okay, and since this is sorted, only the bigger element than 3 is going to be occurring. Okay, so in that case, we will do what is we will increment the 3 pointer again to 4. So now we see that since second pointer was at 4 and we again had a 4 here, if both of them are matching, so we will add it in our answer linked list. Okay, and we will increment both the pointers. Now we can see that we have a 6 and we have a 6 again, so we will keep it in our answer linked list. And then now we move further. So now if we move further, we see that we have reached the null node, so we will stop the iteration there. Okay, so I hope you are clear with this particular approach, by the end of which we are getting our answer. Okay, so let's go through the solution once. All right, so this is the code that we have. Okay, so I made a new node that is head. Okay, and that is pointing to x, so x is pointing to the head, right? So what we will be doing is we will be iterating through both the linked list. All right, and there can be three cases. Okay, so if my head one's data is less than head two's data, right? So in that case, what am I going to do? I will be incrementing the one pointer which is having the smaller data, right? So since head 1 is smaller than head 2, so we will be incrementing head 1 equal to head 1's next. Okay, so there can be the second case wherein the head 1's data is greater than the head 2's data, so in this case we will be incrementing the head 2's pointer. Okay, and in the third case wherein both of them are equal, in this case what are we doing is that we are first adding this particular element in our answer linked list, and then we are incrementing both its pointer, and we will also be incrementing this particular pointer. Okay, because so that we can add a new element again. So that is what we are doing here. H1's next equal to head 1, that is we are storing that particular element inside our answer linked list. H equal to h next, that is we are incrementing this particular pointer, and then we have a head 1 equal to head 1's next, head 2 equal to head 2's next, and h next equal to null. See why we are doing this, because we do not know that at which point this particular iteration is going to end. So every time I'm adding a new element, I am just keeping its next pointer to null, so that where it at whatever instance this particular program is stopping, I will have my made linked list. Okay, the answer linked list. So that is what we are doing, and at the end we are just returning the x next. So since x is pointing to h, so which is having a node value equal to 0, so we are just having all the answer linked list after this particular node. Okay, so that is what we are doing. So I hope you're clear with this approach. Thank you.